of the diodes, Zener diode, p-n junction diode, Scotchy barrier diode, many diodes. But basically, diodes having a similar property that in forward bias conditions, it will conduct the current and it pass through another direction. In negative bias, it will restrict the flow of current. That is the main use of diode. So why I need a diode here? See, there are three cells arranged in an electrical way that is arranged in a series fashion. That is positive of this cell is connected to negative of this cell. And positive of this cell is connected to negative of the third cell. So similarly, from the third cell positive and the positive cell negative. I have installed diodes in three stages. That is parallel to every cell. Similarly, parallel to every cell. But what I have done here is in the reverse bias condition. Why is a reverse bias condition? When it is a forward bias condition, the resistance between the panel and the diodes will be taken into account. When the resistance of the diode is less, the current will easily forward through the diode, not taking the account of the cell. So I have placed this diodes as negative biased. So there is no current flow through the diode. It flows through the cell in a normal condition. So the output of your cell will be collected in the edges. That is a positive and the negative. Okay. When the diodes came into action, you can imagine the cell 2 is fallen under a shadow. If cell 2 fallen under a shadow, what happens? The current from the cell 1 will pass to the cell 3? No. It has some restrictions. The resistance of the cell 2 is increased because the shadow fallen on the cell 2. So the cell 2 starts consuming power which is generated from cell 1. Okay. If starts generating, the bias of the diode is changed because the generator now becomes as a load. The generator in the sense, the cell as a power generator. The power generator now acts as a load. So in load condition, the biasing of the diode is forwarded. So the diode came into picture and forwarded the current which is produced from cell 1 to cell 3 because the diode is the least resistant path here. So the diode is taking the advantage of that and passes the current to cell 3. This is a simple thing how well bypass diode works for us. Can we install a bypass diode to all the cells in the panel? See, this is a simple example when the bypass diode came into action. See, there are 4 number of cells are taken into a group and parallel to the group, there is a diode placed in a reverse bias manner. Then a shadow falls on this cell. That is the last cell. Please make a note of my cursor. The last cell is shadow. Okay. If there is a shadow, then the generator acts as a load. As we said before, it starts consuming power from other cells. Then the diodes come into picture and makes the current which is generated by the adjacent group to the next group. It saves the cells from another electrical aspects also. We will see later, that is hotspots or something like that, and electrical parameters. Okay, this is the thing. This is a conventional solar panel with a diode arrangement, because placing a diode in a solar panel is a very complex design. When we are placing into all the cells, it's a very complex design, and where we can place it, we can't able to think so. And a small doubt. Have anyone seen a solar panel with 3 or 5 or 7 columns like this? If it is like this, have you seen a diodes in that? The answer will be no. You can see the solar panels comes nowadays will be mostly of 6 columns. Why? Because the placing the diodes will be very easy, and it makes the design very intact to make all the diodes in a single terminal box, and we can get the output from the terminal box. This is the normal conventional solar panel what we are getting or what we are installing in a site. So it has 3 diodes with 60 cells. For example, we are taking 60 cells here. See, there are 10 diodes and 6 cells. So it is a
આમાં લખી દે બધું. પેલું લખી નાખ આમાં. આમાં વારું લખી નાખ. ચાલ લખી નાખ. દોરેલું છે ખબર નહીં પડતી. જા.
Box as a diodes and the bus bars and the output cables, everything can be taken from the terminal box. This terminal box is placed backside of the panels. It's IP68 protected and everything, so you can see the terminal box itself. Yes. Bypass diode working. How will bypass diode work here? We have elaborated this thing before. The bypass diode works when the biasing of the diodes is changed. So when the biasing of the diodes is changed is when the solar generators is changed as a load. So when the load is changed, when the biasing of the diode is changed, the diode makes a conductive path and passes the current to the next group of cells. Here there is small one more adding thing here. There is an interruption. You can say there is no bus bar connectivity between these points. See, there is a bus bar connectivity. Please make a leave on my cursor. There is a bus bar connectivity here. But here, there is no bus bar connectivity. The bus bar is damaged. If the bus bar is damaged, you are making a 1000 volt string. In a 1000 volt string, you can say there are more than 20 panels with 60, more than 1000 cells. If it is more than 1000 cells, if any bus bar between the cells is damaged, then the power from the one end is not traveled to the next end because there is no electrical path between those, physical connection between those. In that time also, the diode makes a favor for us and transfer the power to the next medium. Okay, another small question. Please make a note. How many diodes are in a 72 cell module?
6.
How many modules?
6 diodes.
How many diodes are in a 72 cell modules? Yes, many answers are coming. Yeah, quick. Yes, we will go through that. Many answers are correct. Yeah. 3. That's why because it is a 12 cross 6 pattern. Most probably it's a 12 cross 6 pattern. The 6 columns will be divided into 2, 2, 2, and 3 diodes are placed in between them. A shadow on solar panel. Have you looked about the shadow in the solar panel? When you are designing, you may ask your solar design engineers how they are looking the shadow. Shadows will be their own enemies. They think that shadows will be their own enemies. When it is fallen on you, when you are walking in the road, that will be better. But it is falling on the solar panel, that is not better. The shadow on solar panel. Here you can see the left picture. That is only one picture is showing now. The left picture. It is a shadow which is falling on 6 cells. That is 1, 2, 3, 4, 5, 6 cells of 20%. That is 6 cells with 20% of coverage with shadow. And look at this picture. There are 10 cells. The shadow is falling on 70%. Okay. In both conditions, I can say the right side panel will give more output than the left side panel in the screen. Why? Because the shading is affected to all the 3 subgroups. That is, this is one subgroup I can say, that is one submodule. If you are saying this is the solar module of 60 cell, then this 20 cell is one submodule and another 20 is another submodule, another 20 is another submodule. So the shadow falls on all 3 submodules and the resistance between these 3 submodules is same. So the bypass diode is not engaged, and then the power generated by these 18 cells will be consumed by these 2 cells, not by fully. Some amount of power is consumed by these cells. So huge power loss will be happened here, and also the cell which is consuming power creates more heat because of the high resistance caused by falling shadow. When you're looking at this, the right side picture, 10 cells are falling in the shadow with a 75% coverage of cells with a shadow. But I can say this panel works better. Why? Because the diodes completely bypasses this group of 20 cells and make these 40 cells very effective for us and gives a huge output. The huge output in the sense comparing to the left panel. Huge output. Hotspots. What is hotspot? Something is related to mobile network or something. No. Hotspot. We are saying here is a thermal hotspot. What is thermal hotspot? We're discussing more about resistance, shadow, heat, everything. That's the same here. When a cell is falling under a shadow, or when the cell is not producing any power, when the cell loses its efficiency or not producing any power, then the cell starts consuming the power which is generated by other cells. So look at this cell, the yellowish cell that start consuming power from other cells, and if it is start consuming, where it utilize that, there is no point to utilize the power in the cell. So mostly that will be as a heat loss. So the cell starts emitting the heat. When it is emitting the heat more and more, at some point of time, the cell, behind the cell, the backsheet going to crack. Then the backsheet will crack and it may have a serious damage to the electrical bus bars. And when the backsheet is cracked, it may leads to a leakage in the system. If it's an improper grounding, the leakage will be a very big issue. Very, very big issue. So that thing should be called with the thermal hotspot. When the thermal hotspot is created, as already discussed before, when the cell starts consuming power rather than generating. Okay, there's a small question. If a shadow falls on a 6 cell in 3 different diodes group, this is one scenario. And the shadow falls on 10 cells in the same diode group, which one provides better performance? Yes. We discussed just 2 slides before. Yes. What's your answers? Please give a quick answer. Quick answers. I can see many of those are joining now. Welcome you all, but database counts are doubling. And starting is now double. Yeah, we can go on the answers now. The shadow in the same group as we discussed. The shadow in the same group. The diode will engage into the action and bypass those sub-modules. Gives us a better performance. Okay, we will now finally we came into the topic power optimizer. What is power optimizer? Why I need a power optimizer in my site? Whether my panel is doing all the things, because we are saying diodes will engage into action and diodes will do all things. But then why I need an optimizer? As we clearly say, optimizer is not made for shadow or thing. It needs for a mismatch, different orientation, soiling, and the degradation, different types of degradation, and the safety purposes. Many advantages are in this optimizers technologies. We will look one by one in this webinar. Yeah. Types of optimizers. First, we can say there are 2 types of optimizers in the system. That is open and closed. What is open and closed? Is when the optimizers is compatible with all the inverter technology, then it's an open ecosystem. We can say. What is closed ecosystem? When the optimizers is only able to generate power when it has a compatible brand of inverter, then it is a closed ecosystem. We all know what are the optimizers in the market. Like this. Okay. Where we need an optimizer. Whether you have a module mismatch, someone may have installed a 100 watts module of 10 numbers in a site with a 1 kilowatt. Then the customer thinks that I am going to extend my plant with another 2 kilowatt or 3 kilowatt, but you are not going to get the 100 watts panel nowadays. And if you are getting the 100 watts panel also, you are not suggesting. Why? Because the area of the module is very big, the area of the plant is very big. So if you are going for a 100 or a 300, the optimizers will make sense on that point. You can match at different voltages, the module mismatch. Even though the modules are you are buying from the same factory, same lot and everything, Every module has different behavior and different losses and everything. But this mismatch is something lesser in initial stages and it will be huge at later on if it is not a branded solar module. And different orientation. Someone may have a question. Can I deploy an optimizer in a different orientation, that is east-west or north-south or something with all the orientations? We can deploy optimizers with degradation. What is degradation? Something where I am mentioning as a solar panel degradation. The degradation of the panel starts from the day one when it is installed. When it is exposed to light, many degradation factors affect your solar module efficiency. So the degradation is the bigger problem. Can this optimizers overcome this degradation factor? Yes. It won't get the degradation proper, but it will effectively collect the power and it will transfer to the load side, that is our inverter side. And safety. Safety is the main criteria when you are installing a solar power plant. Imagine you are installing a solar power plant. If it is a three-phase system in a rooftop, it is about 1000 volt of DC string you are installing in a plant, in a roof, you can say. If there is any leakage or if there is any fire accident, what is the safety you have given to the DC side of the plant? You have given anti-aliasing protection for your AC side, that is a mandatory thing. What's the safety condition you have given for the DC side? Nothing. There will be, the answer is nothing. Yeah. Then we will look into the safety things also. And modular monitoring. Yeah. Modular monitoring, how much watts is generated by all the panels, how many things. Is there any hotspot or something? We can do the module level monitoring in this optimizer platform. And also the same to overcome the shadow effect, that is optimization. These are all the things why we need optimizer or where we need to deploy optimizer. These are all the things. If you have these problems or when you are facing these many issues, you can simply write your questions in the Q&A section. They will answer it into the task. We will look one by one where we need and why we need. Yeah. How a tigo works. The tigo, we can say this is an open ecosystem. It can work with all brand inverters. Yes. If it is working with all brand inverters, I can say this will be independent from commands. Yes. It should be independent from commands. If it is dependent on the commands, then the inverter compatibility will be less. So the tigo works independently. How it works independently, how it senses whether the panel is performing less or performing low or something like that. See, the left side picture you can see that is a 150 watts generating panel and the third panel is also generating 150 watts. Similar to that, you can see the pipes which is mentioned below to the 150 watts panel. That is a huge pipe, the diameter is huge in size. But the 50 watts panel has a lesser diameter pipe. So, is the water flowing from this 150 watts panel will flow through the next 150 watts panel via the 50 watts? The answer is no, because the diameter of the pipe is too small and it may be a small blockage in the system. The blockage we are mentioning in the electrical as losses in the system. Yes, how can you overcome that? Tigo comes with a method called impedance matching. What is impedance? It is, you can say it is relative to the resistance. You can Google it and make it that thing. It comes with the impedance matching technique. It completely measures the resistance bit of the panel. The voltage and current bit. When we are having the voltage and current, we can easily measure the resistance. So the tigo is connected to a solar module. It will completely analyze the resistance of the module. If the resistance of the module is getting higher and higher, it creates a tunnel like this. You can see the 3 amps current is passing through a tunnel. Like I can drag in here, right? So the 3 amps current is passing through a tunnel. If the tunnel is present all the time, no, the tunnel is not present all the time. The tunnel is created when the resistance of the panel is increased. Okay, when the resistance is up and nearly to zero, then the tunnel is closed. So like the same, you can get the more power. The the 5 amps is effectively transferred to the next side using this tunnel technology. That is, we can say impedance matching technique in TIGO. That's why it is compatible to all the inverters. It's a small comparison between selecting an optimizer. So most conditions they can say the functionalities of optimizers are same, and I can give you some differences between these two technologies. This open and closed. First point, all inverter brand compatibility. Whether it is compatible to all inverters, that is, you are having an X brand, Y brand, Z brand. Whether it is compatible to all the inverters, yes, Tigo is compatible to all the inverters. You can say the open ecosystem is X, and other brands are, I can say here. So then other things will be compatible to A only. If you're having an A brand optimizer, then you need to communicate or you need to connect that optimizers to A brand inverter. So the inverter and the optimizer should be of the same brand. Then only it will work. So the all brand inverter compatibility, no. Whether the MPPT function in module level is happening, yes, then only it can effectively transfer the most of the power to the next level. So the MPPT function is happening in module level. Third point, boosting panel voltage. How it is effectively transfer of any power. Whether it is boosting any voltage, working any voltage. Okay, take a simple scenario. You have designed a system. You are having a 1000-volt system that is 3-phase. You have connected a string of 950 volt DC connected to an inverter. When the optimizer boosts the output voltage, what happens? If it is a 20 optimizer, each optimizer increases 3 voltages, then the voltage in the string is 1010 at standard test conditions. Okay, then the problem will be huge. You can't able to claim the warranty for the inverters also. So in open system, that's why Tigo is not boosting any panel output voltages. The voltage it is getting will be passed effectively to the next group. It's not boosting any output voltages. In closed ecosystem, it needs. Why? Because these inverters will only convert the DC into AC. All the voltage boosting operations will be taken care in the optimizer itself. It has a small disadvantage also. We will look into those in the next one. Continuous operation. What is continuous operation? When you are deploying the optimizer, whether it will work for us continuously in open ecosystem, it's no. It only operates when there is a resistance mismatch or high resistance. Then only the optimizers will come into action. So in open ecosystem, that is Tigo, it won't work for continuously. In closed ecosystem, it needs to work because it needs to give a certain voltage to operate the inverter or to deliver the power in the AC side. So it is continuously operating. In this thing, when you are continuously operating the power electronics in 25 years, when you are thinking about a plant life, 25 years, you are losing the power electronics efficiency, right? No power electronics will be able to 25 years continuously operating in the solar tree. So it has a disadvantage. And one more disadvantage is this. You are installing 10 optimizers in a row, 10 optimizers. So 2 optimizers are fallen under the shadow. It is 2 panels are fallen under the shadow. So the 8 optimizers are supposed to increase their voltage to match the voltage of the inverter. That is, if optimizers are producing 80 volt in a normal condition, if the shadow falls on the 2 modules, it needs to increase to 100. Then only you can get the 800 volt output to convert the DC into AC power. So in that case, the burden on the shadow-free optimizers will be higher than the shadow optimizers. A selective deployment. What is selective deployment? Can I install a solar optimizers or a DC optimizers to only the panels which has shadows? Yes, you can have the flexibility in that ecosystem. Yes, you can operate. What is self-consumption? Because all these optimizers and the module level things are happening via the power electronics. So the power electronics need very less amount of power to operate itself that will be consumed from the connection what we are given from the panel. Module level monitoring. Module level monitoring, yes, we can do a module level monitoring of power, voltage, and current in all the time in a minute-wise data in a tigo portal that is completely free of cost when you're purchasing the monitoring tools itself, lifetime free. Yeah, works without any command. We already discussed it works without any command. Yes, the tigo works without any command. Isolate module to a safe voltage. When it is isolate modules to a safe voltage, that is a question, and we have forthcoming slides for that. But it will isolate modules to the safe voltage. What is isolating modules to the safe voltage? Getting the voltage of the output optimizers, that is output of the optimizers will be zero. Even though your panel is able to deliver 40 volt, 45 volt, the output of the optimizer is zero. That is what bringing down into a safe voltage. How it can be achieved is we can see in the forthcoming slide. Yeah, another short question. Does optimizer needs power to operate? Please. Yeah, you can write your questions. Oh, sorry, you can answer. Also, you can write your questions. No problem. Yeah, I can see. Oh, very specific answers. Also, I can see more specific answers. Yes. 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 We will go through that. Yes, a very minimal amount for their self operation. So this is the answer for that question. Congrats to all who said as self-consumption. Yes, it's a very correct answer. Self-consumption. Yes. Yeah. So we discussed before both the products we discussed. What is optimizer and what is a bypass diode in a panel. When optimizers come into action and when bypass diode will engage into action. That is we're discussing now. So you can see these three images that is the left and the middle image. You can see that a branch of a tree shadow is fallen over the panel and it is covering all the three subgroups and makes the production of the panel less. And you can see the second photo. There is a small branch of tree, very small compared to the very small branch of tree is fallen on a short solar panel to a three cells, a three group of cells. And there is a pole shadow which is falling only to a cell. Okay. In these three conditions, I will say the bypass diode won't engage into action because we already discussed the first scenario. That is all the resistance of the all will be same. So there is no resistance mismatch. The diodes will not engage into action. The first scenario is good. The second thing, the same. The second and third, I can drop into a single point. So the generators, that is solar cells, is falling under a shadow. It's not easy to engage the diodes into action. Why? Because it doesn't. Is it audible to everyone? Hello? Yeah, Tyagarajan, you are audible. You can continue. Yeah, thank you, sir. Yeah, thank you. I can club into two pictures, that is figure 1 and figure 2 mentioned here, into a single point, that is, the diodes will not engage into action. When the diode will engage into action is completely depends on the MPPT voltage where the inverter operates. When the inverter operates at a higher voltage side, that is near to the 1000, the diodes won't engage into action because there is no reverse current or there is no more current traveling. When it is 1000 volt, the current will be less, so the diodes won't come into action. So when it is a lesser voltage that is near to MPP, then the diodes easily engage into action. We can say that every time the inverter operates at the point where diodes are engaging. So that's why we came into the picture called optimizers. Yeah. This is, we can say, the selective deployment. Many of us are in a doubt. Where can I install an optimizer? Whether I need to install an optimizer for a full plant. If you're having a 100 kilowatt plant with 300 modules, it's installed. Roughly, we can say the 330 watts module of 100 numbers is installed in a plant. Only 2 modules are fallen under a shadow. Whether I need to install an optimizer for all the 300 modules to overcome the effect, or I need to install for all the 20 modules in a string to overcome. Yeah, we are having the answer. First, we will look into the first thing. The inverter has only one MPPT and it has only one panel falls under a shadow. So it is optimized with the tigo optimizers. So you can deploy whether it is a single MPPT. Blindly you can install a optimizer to only the panels falls under shadow. No need to worry about deploying all the panels with the optimizers. Okay, coming to the second MPPT, dual MPPT model. Dual MPPT model. If you're having a dual MPPT also, I can say you can install panels, optimizers to only the shadow falling panels. How? See, the MPPT1 has only one string. The MPPT2 also having a one string. In this scenario, you can install the optimizers to only shadow falling panels. Coming to the third thing, if you're having a single MPPT inverter, okay, then you're having a 2 string. Only one panel is falling under shadow or 4 panels falling under shadow. You need to deploy the optimizers for all the panels which is connected to that MPPT. Why? Because already we discussed that tigo works with the resistance, that is impedance matching technique. When it is an impedance matching technique, if you are deploying only 4 optimizers, the resistance of the inverter and the other string is different, and the resistance of the optimizer and the string is different. So if the resistance is different in a single electrical network, then the tigo optimizers will be effective and not effectively used. So it can't able to find a correct point where it has to operate. So deploying optimizer to a single MPPT inverter, if it is a single MPPT or you are having 2 or more string in an MPPT, you need to deploy for an MPPT level. That is like this. In the MPPT, all the strings has to be, all the panels has to be optimized with the same optimizers. Yes. Safety. Okay. If you have gone through the internet before 2 years, this is a very famous picture for the solar industry. Many of us knows. We will have a short 1 minute time to answer this thing. From where I have taken this picture. Anyone knows? Please type your answers. From where I have taken this picture. This is a very, very famous, happened in US. This is the blue. Very famous retail store got fired in the US due to solar. Any answers? Yeah, some people are answering. No, this is not the answer. Yes, next. Okay, I will look into that. This is the picture I have taken from the internet. The incident happened in the March month of 2018. This is the famous retail store called Walmart. The Walmart roof got fired. This is not the first incident. This is the 7th incident the Walmart roof got fired in the United States. So, the root cause of this problem is noticed that this system having a low thermal hotspot and it creates the backsheet to crack and the cell bus bars to be busted. In that case, the improper grounding and the leakage caused the system to fire. So this is the seventh incident happened continuously to Walmart. So they are having a bigger trouble in this. They installed two or three with the same installer and same modules. So they are thinking about that, and the lawsuit is also going against this company. So we are installing solar modules and check whether it is compatible with all these things. Okay. Safety. How we can give safety with these conditions? Why I am including this picture into this seminar? Yeah, because we have in the thought, we can say TIGO provides the solution for this problems. How? TIGO safety schematic. What is TIGO safety schematic? How TIGO save our solar modules or save our plant or save our property from fire? Yes, there is a device called TS4F, that is fire safety. We can mention that F as fire safety. That is, you have to install all the optimizers to a panel. So the optimizers are connected to the panel, and the output of the optimizer is connected to the PV inverter. The PV inverter starts working all the time. There is a simple device called, you can see, the TIGO RSS transmitter. It is connected to one of the conductors of the TIGO output cables. That is, whether it is a positive or negative, you can install these things. When there is a heat or something happens, the TIGO RSS transmitter will give a power line communication signal to all the TIGO safety devices, that is fire safety devices. And these fire safety devices completely takes that module output voltage, that is optimizes output voltage to zero. So there will be no voltage falling or no leakage will happen in the system. Then you can overcome the fire like this. This is one of the TIGO safety schematic. This product is only for fire safety. Okay. When you're installing this, you can overcome the fire safety. Many of the tenders and many of the customers are asking now, what is the safety you are providing for fire accidents and something. So this is the solution. And how safety is achieved. There are various ways we can find that the site is abnormal. That in that conditions we have to make algorithm, and we can get those safety features in time. Okay. So it is actually the rapid shutdown. The rapid shutdown we discussed before is getting the module output, this optimizer output voltage to zero. How we can get? We are the self-isolation. Self-isolation is the point we can get in that. So one thing, if it is any over voltage or over current or over temperature in the string or in the module, then the TIGO will drag down the output voltage to zero. Another one more condition it drags down to zero is AC disconnect. Whether the AC disconnect is when there is a disturbance in AC or there is no power supply, the TIGO will completely take the module output voltage to zero. Okay. This is a module level monitoring. When you are going for a module level monitoring or you need a rapid shutdown feature, you need to have these two devices, that is TIGO access point and CC. The communication between the tap and optimizers will be of wireless, and the TIGO access point to cloud connect will be of hardware communication. Then the CCA will upload all the data via Wi-Fi or LAN to the cloud. We can get those DC data, and we can achieve the rapid shutdown feature also with these two devices. Without these two devices, we can't achieve the rapid shutdown feature because something has to command this for rapid shutdown with AC disconnect. Otherwise, the over voltage, over current, and over temperature will be made by the self decision in the optimizer itself. That no devices. Okay, short question. What is the communication protocol in the TIGO fire safety device? Quick. Running out of time, only 30 seconds. Yes, many answers are correct. That is a power line communication. Yes, because to achieve the easier way, the power line communication will enable us to get better thing. And now I can say the initial slide, the shadows will be bigger and the optimizer will be smaller. Now the shadows will be smaller than the optimizers. Okay, many of you have a good idea about optimizer